Oh, see, we need to connect that. So, how many? Thanks, thank you. How many of you have been able to do the homework? All of you, can you put your hands up? All of you or not? Did you find difficulty to do this? Was it easy? So, how did you do that? Did you develop a spreadsheet, or can anyone present or send the email probably? What's the best way to? I want someone's Excel spreadsheet and put up there. Can you do that one to send me? I don't know what's the best way, Dr. Akshoy? One of their, or do you have an USB? Anyone has got want to show that numbers? I want to see. Maybe, ma'am, you have got USB or on? So maybe Shalini, is Shalini here? So can you get USB from that ma'am and put that on the? Or anyone else has got also? I want to see some other spreadsheets too. Can you anyone also keep ready? If you have USB, or directly you can connect to your computer just in case if you need it. Do you have US, what they call that other port to put on the? So no, you don't. Okay. So what's the best way to present? Okay, then copy it and then give it to me so that I can put directly on the screen. Do you have anyone else has got on USB? Can you copy on USB or send to Shalini that I can get it? So how did you? Okay, so let's, while madam is working, how did you go about this tutorial? What did you do? Google search, I guess, right? Is it done? Let's go. And then I'll come back to this. That way. Yep, that's right. Good. Is that the E1, madam, ma'am?
Yes.
And then
CO2
emission Excel, fantastic. And I'm hoping that will directly run through. Thanks a lot for this help. Great job. Hope we'll be able to open it by the way.
Whatever you're doing on your laptop, that file is also transmitting to the online.
Yes, that's fine. No issues.
Everything you are working on your laptop. Like if you have opened the Word, it will be transmitted over there also.
That's okay, I think. Yeah, okay. Yeah, that's fine. But this Excel is not open. Yeah, yeah. Can you? So say this one I want to open it, or the other one. Can you try the opening that one? I think we can see that one, right? Screen? Yeah, good. So, I think yesterday we discussed the job was clear, right? So, we have got power sources, isn't it? Actually, we can say power generation sources. It could be fuel, it could be various types of electricity generation, right? Now, we know the installed capacity, and somebody I think presented somewhere, I can't remember yesterday, who is that one? That was quite old, 2017 number I think, but this is quite, I think for India, since as far as we know, this is relatively recent. So, now that many megawatt, that is the share you got, and that's I wanted to forget, and thanks ma'am that you also got the sources. I wanted to let you know that you should also have some sources where you have got it. So, another column maybe. So, we are talking about one sort of that's, what's that unit ma'am?
That's in grams.
Gram
Grams CO2
per 1 kilowatt hour. Okay, now we have to discuss that one. Okay, anyway, so that 950.95. Okay, that's good. Now, one, so let's discuss what's that unit is 1 kWe. What's that unit? Kilowatt hour electric, isn't it? So, okay, I think I have to go a little bit basics maybe. Is that what is the difference between kilowatt and kilowatt hour? Is that going live? That's fine, yeah. So, should that be kilowatt or kilowatt hour? That should be kilowatt hour, okay, right? So, kW, and generally I put, to be pedantic, K should be small letter, W capital letter, and then H, kilowatt hour. 1 kilowatt electricity you use for over 1 hour, 1 kilowatt hour. As you said, kilowatt is power. So, now that the gram CO2 equivalent, sometimes people say CO2e or CO2 equivalent, it is not a straight CO2 equivalent. We will discuss more as we go along. So, you got 950, and that is why if you convert to kilogram divided by 1000, simple, is not it? That is why 0.95. So, coal we get 0.95 now, and that comes from where? That is anyway some source, and depending on coal, it could be black coal. Within coal there are varieties of coal, as you know. So, that is why, so 0.95 reasonable. Yesterday I said 1000 or 1, it is 0.95. So, close enough, that is good. Then lignite 1.3. So, I think we discussed yesterday, isn't it, that 30% higher. Gas, yeah, it depends, I do not know, I would like to get some source. Anyone has got a, okay, let us, you got 0.46. Anyone else? 0.495. Anyone else? How much you got? 0.42. Anyone? 0.5. Anyone else? What you have got in the back? Point same, 0.35. I think it's a bit tricky because gas power plant has got number of, they call it combined cycle. They can close turbine, there are gas turbine combined cycle 1, then you can, this one is gas turbine, what this one you have talking about, this one, this looks like very efficient plant. So, it depends how you run the plant. So, ordinary plant, that is standard gas turbine electricity generation, that is probably 0.6 or 0.7 even 0.6, sometimes people put 0.55, but not below 0.55. Now, if you say gas, we are talking about natural gas, right? What about other forms of gas, and what are the other forms of gas? And can anyone tell in the back that we have got natural gas, what else we use gas, what other forms? Or say we import gas, right? Sometimes I mean India imports a lot of gas. What form is that? Liquid not LPG, I think maybe I am not sure, LPG may be exported, but for power production LNG, and that is liquefied natural gas. So, basically gas, you liquefy it and regas it, and so if you want to liquefy it, then you would put more energy, right. So, that number would be higher if you use LNG based power. So, gas, when we say gas, gas is not gas, you know, gas has got, as I said, there are types of gas. But anyway, so 0.35 maybe I would like to have some source, and that is my feeling is that it is very efficient plant, and that is why they are showing that one. They call it even tri-generation, isn't it? That is maybe with the gas. Diesel 0.85, I think we just discussed yesterday. Solar 0.06 to 0.15. So, 1.5 is 150, that means, yeah, 60 to 150, a little bit high end 150 I would say, but I think 100, I say roughly 100 plus minus say 30%. Hydro is very small generally, but again depending on the life of the dam. So, if it is, you can extend the dam life and you can produce, because hydro is sometimes seasonality, isn't it. So, if you say 6 months you have got good electricity, other 6 months you might not have, and more electricity you produce, because that is the calculation they do over the lifetime. So, life cycle basis, and so that varies. So, that is why number is small. Wind, yeah, looks like 3 to 22, but again wind, I think Shalini has got the latest number somewhere depending on particularly Indian situation, isn't it? Can you remember, Shalini? What was that number we got?
Sir, I got
5. Okay, so that is the Indian scenario. So, that one, and again wind has got a one important what I say key influencing factor, what is that, Shalini? Main item or main variable which affect that CO2 footprint? Capacity factor, that is the one thing. So, and what does that mean? Yesterday I think discussed. Can anyone tell me what is capacity factor? How much percentage you are running and actually running the plant, right? So, that is one. So, for wind, what is the capacity factor in India, Shalini?
So, like for Rajasthan and for different states, vary from 20.5
To
29.5.
so, you heard Shalini what she said, 20.5 to 29.5, it can vary that capacity factor within India depending on geographical location state. Okay. So, that is wind. Biomass, that is 0.230. Sometimes some people say biomass nearly 0. Why is that? Do you know? Any idea? Nearly 0, low emission. The reason is that if you burn biomass, you can grow it back again. If it is a sustainable, basically biomass growing takes CO2 from the atmosphere. So, amount of atmosphere you release, same amount of atmosphere you get back. So, that is a kind of cycle, that is why they put biogenic CO2 generally 0, but anyway that is some number. Nuclear, that is interesting one, 6. So, that is fairly low, right. Again that they have got lot of, okay. So, another work, you Google my name and nuclear energy greenhouse gas emission. So, that will give the picture of the range of CO2, and I think our one was 40, but again one of the thing we need to make sure this is not a single number, like say this is a range. I would like, okay, next maybe homework, when keep in touch, keep in an eye, that number is not a single number, that can be say anywhere between 950 to 1100 maybe. This number could be, nuclear could be 6 to even up to say 200, something like that. So, I need to know that range also, okay. And a small hydro, waste to energy, I think that some numbers are there, looks like. So, what we discussed, do you understand that so far, what we have discussed this exercise? So, CO2 emission to send 1 kilowatt hour energy, 1 kilowatt hour electricity, if you want to use that much CO2 is emitted in the atmosphere. Is it clear? Okay. So, now another couple of jobs in the today you do, because everybody got a spreadsheet. Who has not got this spreadsheet and couldn't develop it? Everybody has that. Who has not got that spreadsheet? Can you please put your hands up? So, everybody got a spreadsheet like this, okay, your own spreadsheet, you have got a number, you did not get one, right? Right, that is fine, you can put in the spreadsheet, okay, because that will do some calculation which will be useful, okay, put in a spreadsheet environment. So, those who have got the number, put in a spreadsheet environment. Now, what we will do, we will generate an, oops, what is happening? Anyway, that is fine, we will fix it. So, next what we will do, we will have one more column. We want to know for each of this system for India, how many megawatt hour or kilowatt hour electricity generated. Can you do that? How do you do that one? Tell me, anyone tell me how you will do that one, or let us do that exercise now. So, I have got a column of electricity in megawatt, right. I want to know how many megawatt hour electricity produced from that plant. What is the approach we should take? So, theoretically I am saying. How do you do that one, Shalini? That is right.
You have to multiply the capacity factor with capacity to store capacity.
That is right. Okay, so I need to do that one. Let us a minute. Yep, that is okay. So, that is we are back. So, we have got megawatt electricity, right. Okay. So, that is coal, we have got 203 gigawatt plant. Now, I want to know how many megawatt hour electricity produced from that plant. As Shalini said, what we do? You multiply by capacity factor. Okay, now then you need a column for capacity factor, right, for each of these plant. So coal is generally, so okay, so your job again, one column capacity factor and source you need to find. Next time just do the reference, okay, where you have got it, just one reference, wherever you got it, one number. Okay, so that's one column, and then you do that once you have the capacity factor. So we assume that many hours over the year that is generating electricity, is it? We do that yearly, okay. So I want to know in 1 year how much electricity has been generated in megawatt hour. Do you think you can do that? Anyone, and everyone is clear on that, that you how to do that one? Maybe you do that, let's do that now exercise, okay. It's a very simple, isn't it? So everybody, those who has got Excel spreadsheet, please put the capacity factor, each one, Google it, let's do that now, and then calculate, and finally I want to know how many megawatt hour electricity for each of these system are coming. And then you know, then that's next job. So let's do that one after another. It's a simple job anyway. Then I multiply that by that kilogram CO2. So I want to know CO2 emission distribution of all these, and we want to make a pie chart of all the total CO2 by which the contribution by which one. Obviously coal will be, but we need to know because that's different electricity will have different capacity factor and so on and so forth. Do you understand? Is the task clear? Okay, let's do it. Do you understand how I am going? So Shalini, capacity factor for coal fired power plant, what should we use? 47.5 in India. So let's put that. I think it should be higher. Abhishek is here? No? Because Abhishek did that lot of calculation like that, isn't it? Anyone Google it? Have you got in Indian coal fired capacity factor last year or any year? All right. Tutorial. So once this is done, then I'll move to that instruction for the software, etc. So maybe also you divide the task. Maybe this side of the room can do the maybe top 7 and then rest do the other side, and then divide, then we can fill out the column and calculate. Just a moment, I am just so what I do, maybe this one, maybe have to solar. Okay, let us do this one this side of the room. I just block this sorry color, how is do that one, and rest you do the other side of the. So, this side of the room the top ones, and that side of the room is the bottom ones, which is solar, hydro, wind. So, we divide the job. Okay, let us save me. Oh sorry, I think I am saving on your folder, is that okay? And then I will get a copy. So, now who has told me the coal capacity factor, anyone? This side of the room, right side of my right side, your 0.54 seems reasonable, I think, although it is low side, it should be running 0.8 if it is, or 0.7, but we know not all the plants are running properly. So, that is why that capacity factor. So, okay, now lignite, anyone has got a number? If not, we will use just a standard capacity factor probably, but I would say in Indian side usually I put lower side, so maybe 0.6. What about gas plant capacity factor? My feeling generally high because gas is sorry 5%. What is the sorry what was the gas? Natural gas. What is the capacity factor of the gas plant? 5%. Only? No, I do not think that is a good number. I do not think that can be, because you will be losing 95% then maybe you are talking about. Because gas should be high number. 0.9, yeah, that's although it's a little bit higher end, but say let's, for the sake of argument, let's do that 0.9. What about the next one? Diesel, anyone? Throw me a number. Diesel 0.6, good, I think reasonable. Now come to solar. Yesterday I think we discussed a bit, 0.19, let us use that one for Indian situation. Wind, Shalini, I think on an average we should, no, or hydro. What about hydro? Indian hydro, on in a kind of average number we need. It would be a low number, am I feeling? 0.11, it is a little bit low end, maybe let us put 0.2. What about wind? Wind, Shalini, what should I average use? 0.25 maybe for overall India? So, 20 to 29 you said, so I am using midway 0.25, okay. What about biomass? I would say it is similar to 0.5 or 0.6, I do not know, something like that. Check, tell me if any other number you get. 0.56, yeah, good number. So, I think my guess was okay. What about nuclear? It should be high capacity number, capacity factor. 0.92, that is good number, reasonable. Okay, what about a small hydro? Again the same one, like point, anyone has got a number? Otherwise use the 0.56 like the other hydro maybe, isn't it? Which one is the hydro you use? Hydro 0.2, I think that should be low number. Small hydro even maybe even 0.15. 0.25, okay, we can use 0.25. Okay, now next one, what is that one? Waste to energy. So, waste to energy very small number anyway, only 520 megawatt, but still we should use something. Waste to energy capacity factor would be low. How are you? Good. Had breakfast, everything okay? Good. So, what is that waste to energy? Anyone can tell me? Waste to energy, just I can, otherwise I will put a number, does not matter, maybe point. Anyway, tell me if you have a number. So, what I will do now, yearly hours. So, that many, how do I get hours? Can you tell me the formula? What should I use? Times what? Anyone? I want to know yearly hours based on the capacity factor. What should I do? 365 days, obviously, right? Sorry, what we are doing, you know, two ladies here who are joined late. Sorry, you are also one of our participant?
No, sir. She is my sister.
Okay, sister. Okay, no problem. So anyway, so you know, yesterday we did that homework. You know, have you done that?
Sir,
No. So we are trying to fill out that one.
I know, I was trying, but
That's fine, no problem. So we are together, we are doing it. So just if you can keep an eye, then what we are doing. So basically, we are filling one after another column. Okay. So now what's the multiplication factor should be? Tell me. Hour. So I have got a capacity factor. I want to calculate how many hours based on capacity factor per year. So multiplied by what? How many hours a day? Exactly. That's I need. Done. So that many hours we think that plant is running based on these capacity factors. So I can put a comma, I think, simple calculation, hopefully. Something I made mistake. What mistake I made? It can't be that big number. So because it should be 0.6, right? So now, so a plant 200 gigawatt and that many hour it is generating, it is running. So the electricity to be generated, that multiplied by that number. Am I right or not? Do you follow me? So a 1 megawatt plant running 24 megawatt hour electricity it should generate, isn't it? I am running 203 gigawatt plant and running 473 hours per year, because we know the capacity factor is not running 100%. So that many megawatt hour electricity is generating. Am I right in saying that? Right. So add them all together. Simple. That's done. Now the job is real job. So we know factor. I think we need to go back to what the ma'am has done. So what is that? So that one. So that's kilowatt. I think that's the gram and that's the factor. So now tell me kilogram CO2. Actually, let's fix it now. What I want 1 space. It should be kilo small watt hour electric. I think that one. Hopefully, it will pick me. Okay, that's right. And it will be kilogram CO2 per kilowatt hour electric. Am I think I am right, right? No, it's not wrong. That's what I am doing. Just give me a sec. Small kilowatt electric, kilogram CO2 per kilogram hour electric. Right. So that was wrong. That is should be 0.95. Okay. So you follow me, right? What I am doing? Okay. Simple unit conversion. Now tell me kilogram CO2 per kilowatt hour electricity. If I want to say, because that unit I want, ton of CO2 emitted, ton of CO2 emitted. So that is the same thing, this number is the same thing as I would say ton of CO2 per megawatt hour electric, isn't it? Same. So that is why I can multiply that straight. So it is a kind of factor unit less, we can say, times, I hope you are following what I am doing, times that. So that many, if I put all this together, I am hoping something wrong, but I think I need to fix it, I know. So that is particularly this value, because this is a range. I want to keep this range, but say let us do that 0.06 plus 0.15, or what I say, I think better to do that way, So, point is at 0.06, isn't it? 0.60 plus 0.15 divided by 2. What I want to do, that average of that number. I am hoping that is I am doing right. Am I? Right. It's the same way we can tell this equals. I am hoping that you are following me. If you have a confusion, just let me know. Oops, sorry, what I have done. 003. Is that 003? I have given one more 0, should be deleted, isn't it? Yes. That's that one. And that divided by 2, I don't know, I am having difficulty to see it. And then finally, what was that one? That is, so what I want to do, so point, what is happening here? So that one, what I want, equals sign, oops, sorry. Plus, I am just taking a bit of gross average based on that MEMS number. See that one like that, isn't it? Are you following me? So, do you agree with this calculation? Do you agree with this calculation? Yes or no? Yes. Now, say if we do plot, insert recommended chart, maybe, nope, all charts, pie chart, okay, maybe move chart, doesn't matter, new sheet, okay, and then what I want, right. Maybe the title, maybe I don't know, I think how to put better way. So, let me I don't know what I am doing, I am trying to do something, but hoping. Anyway, we can do that all sorts of things, but I am struggling, I don't know what is that. We need to, I don't can even clearly see that one. How do we do that one? Value from cell, maybe value. If I want to do that as a percentage, how do you see that one? Number, maybe percentage, but it doesn't show the right number, I guess. Let me go back to values then, and values and number, percentage, forget about percentage, okay, what values, undo. Percentage, isn't it? That's what I am trying to do. I don't know what mistakes I made.
It's in percentage.
It is percentage?
Yes.
Okay, now if I want to format data level, isn't it? I want to see that in outside end. Oh, no, that doesn't look good. Inside center, no, best fit, maybe. Anyway, so this one, if I want to pull out, no, that doesn't move. No, that doesn't move. Yeah, maybe anyway. So that's what I was going to do. Forget about that too much problem, then what I want to do, I think, so maybe if we increase that size, maybe 14, and then maybe black. Yeah, so that's expressed in percentage, isn't it? So, sir, Dr. Jain, Professor, which one is the culprit? You can see. Yes. Are you getting? So now, first thing, and also we need to know how much tonnage is. What was the tonnages? Can you remember, anyone? We can go back to data, I think, that sheet. So what do you need to do? We need to sum it, isn't it? So equals sum that one, enter, right. So that is, if I say that is in what unit, that is ton, isn't it? So if I say million, is that a million number? So is it 1 billion, do you think? Is it it's a big number. I don't, do you believe it? 1 billion ton CO2 coming from electricity sector in India. It could be. Do you know what's the India's total emission? Can you Google it? India's total CO2 emission. 2.235 billion. I think that's a big number. 2 billion, isn't it? 2 billion, because globally it is probably 30 billion plus, 30 billion, 35 billion from the electricity sector, I am saying. So now you imagine 2 billion CO2, we have already calculated 1 billion almost, isn't it? So where should we attack if we want to reduce CO2? So it's a simple answer, but is it easy? Can you do it? Why not? Tell me.
CO2 emission by coal power plant in USA is 0.164.
Yeah.
Because of the advancement of the technologies.
Okay.
They are advancing to the ultra critical power plants.
Okay.
So in future, like 20, 30, 40, India will be advancing their technology for the coal power plants.
So that will reduce 1 billion to, so what percentage you are saying? What? If you say
0.998 CO2 emission equivalent per kilowatt.
0.99?
As per the graph.
Yeah.
But for USA it is 0.164.
0.164. So basically that 1 billion, I think we know 85% coming from coal, forget about the others, right? It's mainly coal, okay? So 1 billion number 860 million coming from coal, right? So if you say that one, you are saying that is reducing by at least 70% roughly, isn't it? Or 70%, say 70% reduction of 860, so that will, you think, drop down to maybe 100 million, 200 million, right? Something like that. Are we happy with that?
In future we can gradually shut down this plant.
Okay.
But currently energy demand for the country is coming from the coal power plant.
So how long that will take to get from Indian coal power to go to that ultra low critical? You are saying another 10 years, 20 years?
Studies I have done, literature studies, and 2040,
2040. So until 2040, gradually you will be changing the technology, all these coal fired power plant, and gradually we are expecting that will come down to that number, right? That's why we should stick with coal, right? So we should stick with the coal, at the same time you say advancing the technology. And what technology you are talking about specifically?
Currently we have supercritical power plants that how we process them.
So at the moment these are all subcritical, I believe, right? Not supercritical. Some supercritical, very small percentage, majority is subcritical. And what does mean by subcritical? Any engineer here, power engineer? Power plant engineer, any idea? What is subcritical and what is supercritical? What's the difference really? No? Any Shalini, or I think we need Abhishek today. So you know that one, that there is a temperature, there is a pressure, right? Steam pressure and steam temperature. Generally I think 500 degree below, and maybe I don't know 20 bar, 25, 30 bar, that's probably subcritical, or maybe even 12 bar. I can't remember exactly because I am not a power plant engineer. But if you go supercritical, you are talking about 700, 800 degrees Celsius maybe, or even 1000 I think. And your pressure goes up maybe 50 up to or 35. Now, what is the problem with supercritical power plant? Why can't we go now supercritical? Anyone? Any guess? We are all engineer scientists here. Why we cannot make or move these power plants to supercritical now? What's the problem? Our equipment is not catered for that, isn't it? You need the larger alloy based everything. So sometimes people say it's more the development of material important how you going to modernize these plants, because material has to withstand that pressure, that temperature over longer term. Is that okay? Is clear? So that's one of the constraint, okay, and that will take time. And then obviously the companies are working on. There are some plants operating. I'm hoping that that's one solution. Okay, so that's one, but I still doubt that will drop down to that level what you have suggested. I am not sure any coal fired power plant below 0.3 even with supercritical. I would say from 1, you know, we are talking about 1000, right, 950, madam, that's you got 950 to brought down to say 300, 400, it's a lot of job, lot of challenges, okay. You need to have maybe high quality alloy to make those kind of equipment which can withstand that pressure. What US suggested maybe potentially another way to do it. Do you know another thing? Carbon capture. And what does it mean by carbon capture? Anyone? Any idea?
CO2 will be absorbed in some way or other.
So from the power plant stack, because
Conversion or after conversion,
yeah.
or just supplying oxygen. These 3 ways, like before conversion, you, in absence of oxygen, you extract syngas and capture CO2, or after conversion, you capture CO2. The various technologies, like you can use calcium oxide for absorbing CO2, and methyl, there's some compounds which can absorb CO2.
Okay, in the back, have you heard what the gentleman said? Yeah, what is said? Can you anyone explain me? What did he say? So you can have capture, you have to carbon capture. That's one thing. How do you do that one? You can do before, you can do after, isn't it? 2 ways: post carbon capture, pre capture. So what you are saying, pre capture, right? So pre capture means you add oxygen. So that's called some sort of looping, I guess. I don't know. Yeah.
You basically do gasification and pre-combustion.
Okay, let's talk about post combustion, post capture, easy way, isn't it? Now power plant, you are combusting coal, right? You are generating CO2, CO2 going in the stack. Do you know what is the volume percentage of CO2 in the stack? Anyone? Any idea? It's not pure CO2, it's a lot of nitrogen going through, isn't it? Nitrogen and CO2, it's a lot of nitrogen. Nitrogen going through doesn't matter, but CO2 is the problem. Our culprit is CO2, we want to target CO2, right? So CO2 is generally percentage about 15, okay? So 12 to 15 they say, but it varies, but roughly say around maximum 15, okay? So for the sake of 220. My goodness. So that yeah, quite.
221 times of the atmosphere.
Atmospheric pressure. So quite high pressure, isn't it? Really super, very high pressure. So you need to have those equipment, more cost, more so many things. Now with the capture, okay. Now one option is the capture. So capture, as I said, volume is low volume CO2, right? You need to get that. First we have to capture, and that what you said, that chemical you go through a bed. It's called amine system. Because we have done lot of we had a lot of work in CSIRO on, and we have got a capture plant, 2 capture plants technology, one of CSIRO, and I have worked one of the with one of them in Melbourne. We have got a pilot plant, even bigger plant also, and one plant I think we are building in USA, one in China. It's kind of licensed, we have commercialized kind of to some extent, but it's still not a lot of people convinced on that because it takes money and oil costly. We can discuss a bit more, but generally the process is that the flue gas coming, you put that flue gas through a bed of absorber bed and amine chemical, and it will take CO2 and leave the other gas as a lean gas, we call it. Okay, so that's right. Yeah, there are a number of amines actually. We are optimizing the amine system. Now that CO2 you captured, you enriched, okay. Now what do you do with this?
Like various ways.
Yeah, you have to store it in the underground. That's called CCS, carbon capture and storage, okay.
And soil recovery,
Yep.
soil recovery for
potentially then you can put in oil field to enhance the oil recovery. So, there are a number of ways and options, but just the capture and enrichment, it is quite costly process, because you have to have the plant, amine and etc. You have to run the plant. You already will lose some of the electricity to do that, and it could be up to 30%. So, we saw that capacity factor, you also another 30% you reduce that. So, that is a for and against argument. Okay. So, it still is it efficient way to do that. So, some people say that because it is a low volume 15% in the stack, can we increase the volume a bit? How do you do that one? You, instead of nitrogen, you put oxygen, lot of oxygen, and that is what you have said, pre-capture. So,
Pre-capture, post-capture, and there's another one, oxy-combustion, where only you
that is the I am talking about oxy-combustion, but one pre-capture you told about,
pre-capture, you don't supply oxygen.
you just get the syngas CO2 and then carbon dioxide and then send the rest of the gas to the power combustion chamber, right? Yeah, that is right. Yeah, syngas. So, three option: syngas production, take CO2 out, right, and then rest of the gas can be burnt, produced, so that your CO2 stream is kind of before putting in the combustion chamber clear. Then another one, you enrich oxygen, so that your CO2 coming out of the stack is more enriched, so you can capture more cost effectively. Other one, but on the other hand you need to put oxygen obviously. Other one is that you are saying just nothing as it the plant running. Do you have any power plant nearby? Have you seen any power plant? I think I saw from the air. Is that a thermal power plant? When I landed from plane, Professor, what is that name?
It's a Prayagraj
power plant, and it is supplying for Prayagraj. Do you know what's the capacity of that plant?
Not really.
And it's running coal. It is a thermal power plant. It's coal. What's happening? Is that okay? All right. I see. Okay. All right. So I'll put that on. So I think so. If say that plant, hopefully, if we want to capture, we just put something on the top of the plant and capture the gas. Basically, take the gas and put through the amine system or capture plant. They call it carbon capture plant, and you do something with it. Either it is store it or enhanced oil recovery, and nowadays people are talking about utilization. So you can make. In my case, I am involved with a lot of projects like that, and that is what we do. We produce green hydrogen, whatever way, then mix with this CO2, you make more natural gas or methane or other, methane obviously natural gas, but other chemicals, maybe other hydrocarbons, as you said, there are many ways. So basically you use the carbon cycle, you close that loop. Does everyone understand that? Is it clear what I have said? I don't know. Is it clear more or less? Anyone has a question so far what we discussed? So these are ways, but these are not simple ways. All are complicated, all costly, and you reduce the power plant efficiency, and you still deal with. Okay, that's CO2. What's the other problem with coal-fired power plants? Anyone know? What about the particulate matter? Sorry. Fly ash, another waste, isn't it? When you burn coal, particularly Indian coal is crappy coal. We call it 50%. Professor, do you know it's quite high ash Indian coal, isn't it? Yes. So up to even 40%. Yes. So say in Australia, we call it really poor quality coal compared to our standard, because we have got very low ash coal and very high quality coal. So if you have poor low coal, that means you have got a big stack of waste fly ash. Although that fly ash is a source of other materials now, say rare earth, maybe geopolymer, maybe your cement, but these are all complicated. Okay. Now so basically I am not in favor of coal anymore. I was, but not anymore. I am getting out of coal. Anything with coal I don't want to hear. Okay. But it's not a straightforward solution either, because we have got coal mines, we have got a lot of employment. It's not I cannot say overnight shut this coal down. Whatever the electricity will come from then immediately. We don't have that choices. Okay. But slowly let transition, and that transition time might be gas, I don't know, but again gas market is volatile, isn't it? So, you know, Ukraine war, suddenly gas market is in the, I don't know, $30-40 per megajoule, which was only $7 per megajoule. So, how many times increased, right? So, coal gas, similar situation, coal to gas obviously reduce the CO2. There are plenty of gas around in US, in Australia, Australia, Qatar, 2 countries we produce lot of LNG and we export it. So, gas is there, but again gas is the same issue with the CO2 footprint. We know that 1.6, maybe you reduce a bit. If you have a very efficient, you can reduce to 0.3, but still gas is insecure. So, now what are the other solutions then we have got? Diesel maybe, I do not know, fuel oil, it is generally expensive. I do not think you have any countries cannot run unless in the Middle East, because they have got apparently oil is cheaper than water. So, but not a lot of country has got luxury, you have to import it, crude oil you refine it. So, life is not easy, right, it is hard. So, now what are the other choices we have got?
Hybrid system of solar wind.
So, we have got next one is solar, looks like, right, solar, after diesel, solar. So, let us discuss about solar options in India. What do you think? Anyone? What is the problem with solar?
Area requirement.
Land requirement. Do we have that much amount land? No, isn't it? In some parts, say Rajasthan, yeah? Where else I think we have got for solar?
In between, there were recommendations like we have large canal structure in India. So
Floating solar. You are talking about float
just above canal,
but
put solar panels.
so that's not floating, not floating on a structure. It will be
Just above canal.
okay,
The canals which is carrying water.
and then on the top of the canal there will be solar.
You have dual advantage. One is like in drought-prone area, whatever canal is there, our sunshine is abundant, so there is evaporation. Because of evaporation, some of the water from canals
Can leave, escape. So you can have that also dual effect. Yeah.
Similarly, for installing solar panels, we do not require fertile land.
Yeah.
So we can use that unorganized land.
Mm.
Gujarat and Rajasthan, so these techniques are
Yeah.
they are putting solar panels on the
That's right.
panels.
So you said that Rajasthan has a lot of land, right? Who comes from Rajasthan here? You. So you know very well. Is there a lot of solar also? Sunshine, good sunshine, strong sun.
Yeah.
That's also available.
Rajasthan has, I think, world's largest solar park.
That's right. There are a couple of I heard of that one. Yeah, that's right. So solar sounds like in India not a bad choice, right? Some opportunity. We are not. Do you think we are extracting enough? 100%? Maybe how many percent is your guess is that we have exploited solar resources in India? 10% already? Maybe 2%, 5%. Eh? So 95% opportunity we have got, right? So what are the major barriers? Do you think anyone guess that for solar here?
First is area.
But you said that Rajasthan has got a land.
Like lifetime, the recyclability, theoretically we can extract all the rare earth metal of whatever minerals we have used in the solar panel.
But that's the life, that's say 20 years down the track, that's the problem. Now, what's the problem now? Cost. So levelized cost of electricity from solar is still expensive, you think, right, in India? Maybe we need to dig a little bit more on these aspects, because these are the important things. Because if you say Prime Minister Modi ask and say recommend me solar power for next 20 years for India, because his job is to give 24/7 electricity, isn't it? He doesn't care where it comes from, right? Well, he cares, but he has no choices, because he has to give the electricity to the people, otherwise people don't vote him, or I mean any politician I am talking about. That's their mandate, isn't it, or their priority. Now our job is to give the good suggestion to them. So do we have that suggestion? I mean, what do you think that? So now your job, I think maybe another homework we need to think of, what would be the ideal combination of CO of the power sources for India to reduce that we want to reduce. What's the Indian target? Do you know that one? By 2070, isn't it?
Yeah.
What percentage? Zero emission by 2070. Eh? So now you see the choices here, the problems here, isn't it? We have already more or less nailed it down that we have got 1 billion ton now, we need to go 0 almost, isn't it? In the how many years we have got in hand? Not many years. It's a 20, isn't it? 30, 40, 50, 60, 70. So 50 years. Is it? No, 40 years, right? 47 years. Nearly 50 years. So 50 years divided by 1000 million, isn't it? So 1 billion divided by 50 roughly. So almost 20 million a year, isn't it? So the solution we need how to reduce 20 million a year by the combining and changing and I guess various combination of that. Does that make sense? This exercise we have got something out of this. Who knew before and guessed before this is the result? Anyone? More or less you knew, right? Anyone else? Any comment on these results? Professor, you want to make some comments about this? That's good. It's not unknown anyway, isn't it? You knew that before. Yeah, that's right. Yeah. So, but it's good to kind of refresh ourselves thinking, because at the end of the day, life cycle assessment give this kind of. That's why we did. I mean, that CO2 footprint, somebody you got from the web or somewhere, everyone you got, they did some kind of LCA on that, and that's depend again scope 1, scope 2, scope 3 emission. You remember we talked about. So we will discuss a little bit more. So in any question, any confusion or anything you want to, anyone wants to say this is this topic kind of over now. Anything else you want to raise now? Everybody is clear what we done? Good exercise. Okay, let's save it, and I think I will copy save as maybe my. Put that here and later I will take it. Okay, that's good, and I can take it off now. So now let's discuss about that. So what do you think this is? What is this in the photo? Wooden shed, isn't it? Also written wooden shed. So, and what's the special about it? Nothing is special really, it's a wooden shed, isn't it? Simple. So what do you need to make it? Wood, obviously wood. And what else you need? You might need nails. That's right. You need to stick. Where wood comes from? Trees or forest, isn't it? Plantations. Actually, I spent, Dr. Akshoy knows, I studied forestry in Bangladesh, forestry science. If I was in Bangladesh, probably I would be a forest officer. They call it a conservator of forest. Actually, one of my students is the chief conservator of forest in Bangladesh, which is the highest position for forest department in Bangladesh. And a lot of my friends, students, they are basically running the forest department in Bangladesh and various places around the world. So I can spend days on that, although I had later chose another career. So that planks we call it, right? Have you heard the planks, term called planks? You know where planks come from. You get a log, you saw it, and I have been to I don't know how many sawmills, because I started my career in forest industry in Australia. Many sawmills, and I think some of the mills I have been multiple times, and most sophisticated mills do not need people. They, the logs are all automated, basically gone through, laser is measuring that one, going through the mill, cutting in a real exact dimension you want, and then you get the planks, okay, and then you stack it, dry it, and you make sir is sitting on that chair or furniture. In Australia we make a lot of, not necessarily wooden shed, but trees for the buildings, like my house is, we call it timber framed house. So timber is essentially used a lot in the buildings in Australia, not only Australia, New Zealand, Europe, some countries. I will show some of these because we have done LCA on that. So you need, so it starts from trees. Now how tree grows, okay, so let's move into that area. So what I want to do, that's the homework will be coming, because you need to do life cycle assessment based, what is the carbon footprint, and not only carbon footprint, other LCA indicators to make a wooden shed. That's your job, okay. And end of this tutorial you will learn that one, and that will take a bit of time, and how we do it I will go through that. So maybe let me move that to another presentation. Hopefully, I am managing okay. Let's see that if that is the expressive. So, I think what we need to do, that will be the, you will be using the software also. I'm hoping that is opening okay. Sorry, just give me a second, because seems like some of these things are not running properly. This one. Seems like I have to come back to that. Maybe let's do something else, I think. Why it is not running properly? Close. Sorry, this took a bit of time. This is the slide I was looking at. We'll go a little bit more detail. So, with LCA, we discussed about boundary, right? And you asked how to set the boundary, right? So, now anything we do LCA on. So, in this case, what we are doing LCA of what? Wooden shed, right? Any LCA topic, first job is to set the boundary and develop a block flow diagram. You heard the term block flow diagram. So, basically these are blocks and how it is flowing, kind of, that is a diagram. So, now in this case what I have done, actually that will be in the software too. The software tutorial you will be doing the CIMA Pro software. So, Shalini, you have given that executive file yet? Not yet, the CIMA Pro exe file. Everyone got that CIMA Pro exe file? Has anyone got? Everyone? Okay. Has anyone tried to install it? Have you installed or not yet? Anyone installed or not? Installed fine? Everyone installed fine, right? Okay, good job, well done. Did you get that PDF introduction to CIMA Pro tutorial, both document you had a look, right? Or you at least you have that one, that is good, it makes life easier. So, what we will do in CIMA Pro software, we will open it, we will complete, it is called tutorial with wood or wooden shed, tutorial with wooden shed example for life cycle assessment, that is the one we will have to do. Okay. Yes, you want to Avash, any question? No. So, block flow diagram. So, we know if you go there, we need to develop and model chain sawing first, because you have got trees, you need to saw it, you need to cut it, harvest it, and that you will be using a chainsaw, and chainsaw will use petrol. Okay. So, you need to pick the petrol from the database, you have a chainsaw model, you feed petrol in the chainsaw, and then you develop chainsaw model and evaluate the chainsaw first. Okay. Then second one is, we call it fell tree. Okay. So, because the tree is standing, you need to fell it. So, fell tree is a model in the CIMA-Pro software, and you will pick chainsawing probably, I do not know, 3 minutes or 5 minutes, you need to add that minutes. Then fell tree model completed, it is like going up, bottom up we call it. Okay. Then I told planks, you know planks, right? In planks, I do not know in Hindi what do you call?
It's plank, right?
Plank.
Everybody understands.
Yeah, I think in Bengali we call it tokta, isn't it? Tokta, right? Yeah, flat kind of stuff anyway. So, planks, and then once you have the plank, because for planks you need obviously you need, then we call it simple shed. So, that will be our wooden simple shed in CIMA-Pro software. What do you need? You need planks obviously. To make planks, by the way, it is going to a sawmill, right? And sawmill will be using electricity, and electricity might come from all these sources we have already done. So, you feed electricity, whether it is from coal or wherever, whatever electricity you have got near the sawmill, you feed them planks, you make it in the simple shed, you get a carpenter or yourself become, in Australia it is called DIY. Do you know what that stands for? Do it yourself. Yeah. So, there is a company called IKEA. Anyone has got the name IKEA here? Here in India IKEA is there? Okay. Oh. So, you know that everything you buy it and do it a little bit yourself. I do not know, that is popular here, IKEA furnitures or not? Popular? Because it is cheaper, is it, or not, or what is the reason it is popularity increases? Very simple, is it? Started, not many IKEA, not many IKEA shops in the country. Where is that, in Delhi or Bangalore? Okay, Bangalore, Delhi. I think in Melbourne we have got at least 3 IKEA stores, massive one, very busy, and many multiple floors. I don't know. Whenever I go, sometimes I think you get also a lot of home design stuff, home decoration, and my wife sometimes send me, and I get lost and I get mad about that. I say I don't want to go to IKEA anymore. So, but there are a number of shops. The reason is that I think people like small. Sometimes it is fashionable, but also very easy to do. You buy all the stuff, you get delivered, and you do it yourself. Must be cheaper also, and apparently they are very sustainable, because all these IKEA is which country? It belongs to Swedish, isn't it? Swedish company, Swedish. So they have got a lot of plantation or even natural forest. I am not sure. They certified apparently what is called FSC. Have you heard that term? FSC certification. FSC stands for Forest Stewardship Council, maybe, I think FSC, and they certify that an wooden item comes from sustainably managed forest. That means amount of trees you taken, you grow that same amount in the next year or year after. So, you have to, if you look at some of the papers, they call it FSC certified. Okay, so they have got 10 principles and accordingly they certify. So, IKEA is generally certified, and that is another reason. So, they get entry into Australian market, other countries also. Now, apparently they say that they can make a whole house. You can get the house and you can assemble piece by piece and you get a house, maybe portable house. So, that is we are talking here, kind of simple shed. You need also, what else you need? Steel nails, and I do not think that is a small item, but yesterday discussed a little bit about, isn't it? Avash's PhD apparently will be on steel making. So, that you need iron ore, you need flux, you need coal, you need obviously electricity. Anything else? So and many other things. So, now you know iron ore. What is iron ore? What is iron ore? Anyone have any idea? What is the compound of iron ore? Hematite, magnetite, goethite they call it, but mainly hematite and magnetite. I do not know in India, do you know anyone is in this kind of business? Do you know whether India hematite or magnetite mostly? Hematite. In Australia we have got a lot of hematite, we have got some magnetite layer. So, generally Fe, Fe2O3, isn't it? That's also that one. Number of iron and oxide. Okay. So, iron and oxide, that these are called oxides of oxide ore. We call it, you know that in mining business it starts with ore, right? Ore, you know, right? Ore is that which is the compound, and you need to separate to make pure metal. So, either it is oxide or sulfide or carbonate or halide, they call it. Majority of the ore in the oxide. So, metal and oxide, it is like, I do not know, I think when I tell young students, it's like girlfriend boyfriend, very difficult to separate, you need to put lot of force to separate them. So then basically this one iron ore, you need coal acts as a reductant to separate them, make pure iron. So, you basically reduce iron, you make Fe, and then that Fe, so iron ore and coal basically, you need also flux, sometimes limestone they add. So, to make 1 ton of iron, you need at least, depending on iron ore quality, say Australian ore, we would say 1.3 ton iron ore there, maybe half a ton coal in various form or carbon in various form. So, that that goes there, and then flux, I do not know, 100 kilogram or 200 kilogram flux. So, that is quite, that recipe goes into a plant, steel plant, it is called obviously blast furnace. We visited in, there are number of, is there any blast furnace professor around Allahabad? Not, this is not iron belt, right? Where is that, any nearest iron blast furnace? Chhattisgarh, Bihar, Odisha, I guess, right? And obviously West Bengal, in Jharkhand. Who has, I mean, isn't it that Tata is in Jharkhand, is it? Jamshedpur? Jamshedpur is Jharkhand. You heard of Tata Nagar, right? And Tata Nagar and Tata, Jamshedji Tata, isn't his name? Yeah. And he is the father of apparently Indian industrialization, isn't he? Steel, that is right, yeah. So, I do not know, Jamshedpur plant, they call it TISCO, isn't it? Tata Iron and Steel Works, something like that. I visited that because I spent some time in Jamshedpur, and yeah, it is a fascinating story. 1914 or something like that, Jamshedji was visiting with a geologist, find some iron ore around near that time in Jharkhand, that used to be called, or something else, that was not Bihar, and then they set up the plant, and yeah, that is how Indian story of industrialization started, particularly steel making. And I do not know, one day I was traveling with a Tata executive from Jamshedpur to Kolkata, and he was saying that he has to travel every week to make sure his supply of goods come in Calcutta, because they need to, you know, lot of development happening. And any of these cities you talk about, say Delhi or you know, what's the lot of, it is in Allahabad too, isn't it? Around Allahabad, lot of development happening, multi-story buildings or not, lot of residential development, and you need lot of steel obviously. And he was saying, I do not know that story, that when 1930s around, I think something, or maybe that when the Tata plant started, they produced lot of steel for Howrah Bridge. Have you heard of that in Kolkata, isn't it? That is one of the, what's the specialty of Howrah Bridge, Dr. Akshoy? So, and no support, it's suspension bridge, is it?
No, it's not suspension.
It's not suspension, it's a, so once two end support, is there any support in the river also? No support, isn't it? So, okay.
During emergency, you can
Open it. So, basically no support in between other than two end support, isn't it? That is the kind of specialty anyway. So, apparently they had excess steel, and that sent to Sydney, because Australia was a colony that time, and Australia was part of British colony. Lot of things actually used to go from India to Australia, and Australian colony used to be run from Kolkata. So, anyway, so that steel ended up in Sydney Harbour Bridge. I do not know how the story and whether that is right or not, but that was I was told. So anyway, so steel making is a fascinating business, and sometimes the country's development is measured by amount of steel you use, and the capacity wise, we told yesterday how many million tons of steel we produce generally. So last year or year before, any idea? 2 billion, and nearly 2 billion, I think, I do not know exact, maybe see, I was following when I saw it was 1 billion, and then last 10 years it became 2 billion. And do you know who is the major producer? China. And how much is that? Half of the steel comes from China, nearly 1 billion they produce China, and that is mainly Australian and Brazilian iron ore. Okay. So that is why so 1.3 ton of iron ore, half a ton of coal, maybe a bit of 0.2 or 0.15 is flux. you put them in, you get 1 ton of what they call crude metal, hot metal, not steel yet, because that is iron essentially. So, you get iron metal, and obviously you need some electricity to run the plant. Okay. So it is quite a bit of activity, is not it, and there must be a lot of CO2 generated there. And then you do the add oxygen and do steel making. It is more, I am not a steel metallurgist, but I think Abbas is going to do a PhD. You have to learn a lot about all these aspects and various types of steel making. So then that goes in the simple shed. Okay, now shed is built. Shed has got a lifetime, right? Say how long? They say 10 years, 20 years, I do not know, whatever put your lifetime. What happens after that shed ends its use phase? It becomes waste, right? What can you do with that? You can recover nails maybe, right? So what else you can do? What do you do with that wood? You can burn it, get some energy potentially, right? Or what else? You dump in the landfill, and that will rot, that will produce some even more maybe emission, I do not know, I think maybe methane, because it is a biomass material. So the waste, lot of people do not think about that waste scenario at all. That is many product we do not think about waste scenario, right. So in LCA, when you do the model, and that is your job to do that with the CIMAPRO software, all these things will do that one, and that is the boundary. We call it, this one will say if we say the tree growing, if we include, because tree, felled tree comes from trees, is not it, and tree plantation, it could be plantation, it could be natural forest, right. If it is a natural forest, that is problem, because you need to, you are destroying natural forest. If you have a plantation, say, and plantation could be radiata pine. In New Zealand and Australia, we have got largest plantation resources. It can be eucalyptus. By the way, where is the wood source in India? Where do you get wood from? Any idea? You import, I guess, is it or not?
Yes.
Or local?
Import as well as
Local. So local, what is species? Any idea? What kind of, is teak or mahogany? Sal. Sal is probably natural. Devdas, was that? Devdaru they call it, is it? And also what is that called? That I know New Zealand export lot of logs in India in the log form, and that is mainly pine, radiata pine. Malaysia, yeah, that is right, Malaysia and some of the tropical trees. Australia does not export, I do not think, but they export, some of the countries export some finished goods like medium density fiber board or plywood or composite. Some was one working on the composite. So there are many ways. So but to grow trees, obviously you need seeds, right? You need land, you need fertilizer. So if you go, how far you can go upstream, that is the question. So that is we call materials taken from nature, because at the end of the day that is our mother, that is our source, mother nature. And you take it, you make it, you all these elaborative activities and do it, and then finally, so why we are thinking all about these ones? What is the reason? Anyone? To make it sustainable. We want to know that where that sustainability indicators are. We want to calculate, and that is the beauty of LCA, that you go so detailed, so meticulously one after another, and you calculate. It should give a number, at least with a range of numbers depending on. So that is why input data is very, very important. Is it clear more or less? Any question in relation to this this one? Okay, now let us go back. So I think how we are going with time, Professor? We can have a break.
break in 5 minutes.
So what I want to do, let us have a break and then come back. 5 minutes means 10:30, isn't it? And then I want to go some few more theoretical stuff, and we can move to, I guess, yep, okay, we can move to other ones. So I think let us break for, have a break, because it looks like people are getting a little bit tired. So get a cup of tea or coffee or whatever, and then come back maybe 10:30, maybe 10:35 max. So we should start 10:35, okay. So how are the online going? Should I stop it?
Yes, sir.
Oh, I couldn't see this.